So for the chapter 14 trig equations, what you guys want to do is anytime you're asked to find theta, right, when it's connected to a trig function. So there's only a couple ways these are going to show up. One way is a double angle, okay, when you want to sub it in from a formula sheet. The other way is when you have two different trig equations and one is squared, right? When it's not a double angle, when it's squared, you want to sub in something from the Pythagorean identity. So, for example, if you guys had cosine squared, what does cosine squared mean the same thing as?
Sine squared. Sine squared.
Close. Make sure the order is right. 1 minus sine squared. Good job. Because what you guys would be doing is minusing the sine squared over to get cos squared by itself. You're missing that?
Just that one and third.
Oh, yeah, sorry. Alright, just you could write it in. I have to go back and change this. I just didn't have time to print and get it all out to you guys. So that was the only thing I changed. That and then the 14. So now if you guys have two different trig equations and none are squared, right? You already did your substitution, you want to factor out a GCF. There's some kind of GCF in there. And if they're all the same right off the bat, just a normal one. So I'm going to kind of go in like the levels that you guys would have. So what we want to look to see is first, you have any kind of double angles, anything crazy going on. No double angles here. This is a nice little one. We have all sine. So when we did these in class, I told you guys if you have all one trig function, what you would do is think about the sine theta like an x. So if it helps you guys to rewrite these, right, we can do that. Okay? So you want to think about how do you solve for sine theta? How do you solve for x? Well, first thing you need to do is distribute through. Sine theta plus 3. Okay, so now your goal is to solve for sine theta. Okay, so you guys would minus your 3. So we have 2 sine theta equals 3 sine theta. Well, if you want to do plus 0, you can. How else would you guys keep going here? Alright, if you need them to do like x's, 2x plus 3 equals 3x plus 3. Alright, you move this over. So we have 2x equals 3x plus 0. How would you guys move this to the other side? Minus 3x. Good. I know you guys don't like when you get weird stuff for equations. Alright, so this is going to be a negative x equals 0 divided by negative 1. So x equals 0? Yeah. Okay. And if you guys get weird stuff like this that cancels, it's okay. Alright. Don't panic. They like to do weird stuff like this. So we have negative sine theta equals 0, negative 1. Okay. So really, sine theta equals 0. What do you guys have to do if you're missing your degree? Good. Second function key. Awesome. So we do second sine is 0. Sine of 0. Right? And we get 0. Now, when you guys have zeros, ones, or negative ones, you got to be really careful because your calculator only gives you one option. Right, the order of pairs, exactly. So just make a quick little chart for yourself. Right, this was your 1, 0. Here's your 0, 1. Negative 1, 0. And 0, negative 1. Now you guys want the sign to be 0. So on your order of pairs, the sign is the second one. So sign is 0 at these two spots. Right, which is, here's your 0, 360. And then this one is what? 180. Close. 180. Right. Now we also need to look up above at our intervals. These are like a lot of places you guys can use points. So with your intervals, you want including 0, but do we include 360? No. So our final answer is just going to be 180 and 0. You don't want to include the 360 because it's close and our intervals don't include it. Good, guys?
So what happens if there was no interval?
Oh, yeah, they'll always give you one. Like, you'll see it for like all the like Regents problems. They always have to tell you something. Okay, so let's see. This is a little bit different. So for example 2, you want to check to see, do you have any double angles? No. All right, we got something squared, but do you have all one trig function? Yeah. So we have a one trig function. So let's make these into x's. Might help you out. X squared minus 2x equals 3. Since your highest exponent is squared, what do you need it equal to? 0. Right? So x squared minus 2x minus 3 equals 0. And then we would have to do our factoring. So x and x. What are your factors of 3 that make it 2? Good. We need 1. We need a minus 3 and a plus 1. We want to get a negative 2. So when you set these to 0, okay, we're going to have x equals 3 and x equals a negative 1. Great. Okay, so just remember that you guys were originally dealing with sines. So it's like saying sine theta equals 3, sine theta equals negative 1. So once you guys get your sine theta, now use your second function key. And when the second time is 3, what happens with that one? Good, it gets an error, because your sine can only go between negative 1 and positive 1, so this one's not going to work. Alright. Oh, good, you got negative 90. Now, if you're thinking negative 90, right, because negative 90, is it in my interval? No, so you have to think negative 90 is going back, like down, 90 degrees. So what would this be the same thing as? 270. Good job. So you want to use theta equals 270, right? Not the negative 90, because that's not in the interval. That's it. Okay. Usually stuff like this would be part of one, not like one of the long ones. I think you guys have one actually tonight in your homework, in the first 14. Okay. All right. So now we start getting into some of the tougher stuff. Okay. Let me get a reference sheet up too. This one hopefully in the back there. Yes, there we go. All right, so your next problem, there should be something bad happening. Anybody notice it? Double angle, good, okay. So the double angle is happening though with the sine. So on your reference sheet, you've got to go to our double angle, and we only have one option for the sine. So you want to rewrite this in for your sine 2a. So we're going to do 2 sine A cosine. But the a's are like thetas. Right, the a's are like thetas. You want to use a theta instead, so it's being all the same might be nice. So 2 sine theta cos theta equals negative cos theta. All right. Well, let's go through the steps up at top. We had a double angle. We already subbed it in. Do you have one trig function? No. No. Okay. So if you have different trig functions after you've made the substitution, right? So if we have different trig functions, right? We made our substitution. We have nothing squared. We want to look to factor out a GCF.
These are all of them five.
You can if you want to. I'll move it all first. I think this one's good. All right. So get this in standard form first. So Frida, you were thinking add this over. I like it. Now, are these like terms? Can I make it like 3 sine cos? No, because they're not alike. This one's just cosine. This one's got a sine and a cosine. So when you move it, it just stays 2 sine theta cos theta plus cos theta equals 0. All right. What do you guys see that's in both terms?
Theta.
Cos theta. Right, you want to see the trig function too. So the cos theta, since it's in both parts, is like the GCF. So we're going to take the cos theta out and make your one bubble. Good job. 2 sine theta plus what? Good. Awesome. By separating this GCF, it like separates the functions. So then you can deal with them each individually. Right, so when we separate these, yep, equals to 0. So cos theta equals 0. Then we're going to do the other side, 2 sine theta plus 1 equals 0. Well, let's deal with my second cos of 0 first. Remember, zero's tricky, so second cos of 0, you get 90, okay? That's not looking good. Theta equals 90. Okay. I'm just going to do a quick little check. Here was your 0, 1. Where else do you guys think there's going to be a 0 in the cosine part? 270, yeah, because this is 0, negative 1. So we have 90 and 270 here. Right, so cosine being 0 happens at both of those spots. Now the other one, when you guys go to solve it, remember minus 1, 2 sine theta equals negative 1, divided by 2. Alright, so your sine theta equals a negative 1/2. Let's see. So second sine negative 1/2. Good, negative 30, okay. Alright, we kind of looked at this before. Negative 30 is not in the interval, right? So what we have to do is think about, well, let's see, negative 30, if I draw myself a little picture, right? Here's your 360 and 0. If you're going down 30 degrees, right, what would you be at? 330, good. So 330 is going to be one of my options. Now, everybody forgets this last part, right? Especially when you're not dealing with zeros and ones and negative ones. You have a negative 1/2 and you're talking about sine. So we want to think, where is sine going to be negative? T and C. Good, we got the C one already, but we have to do it in the T quadrant too. Yes, nice, yeah. Alright, 180 plus 30 is going to give you what? 210. Very nice. Okay. So when we write our options, we don't want to take negative 30. Okay. We want to take 210 and 330. And we actually have lots of values of theta here. And 90 and 270. Okay, so you have 4 answers here. Okay, this would be like, I think like a 4-point question, like a part 3, something like this. Got a lot of steps to it. Right, but make sure you guys remember to check if you're positive and negative and get into those quadrants. Okay, 30 degrees is not going to be one of my answers, it's just your reference angle that you had to use to get there. I don't know, this might be, it might be one of your, could be a 6-pointer, maybe. Yeah, you guys could get stuff like this. So 4 and 5 would be examples of, I think, ways you guys could see a 6-pointer on your Regents. Could be a possibility, right? Where there's just a lot of steps, it's kind of long. Okay, so let's look at the first one. Okay. Notice, and Kayla, you know how you were asking me about the intervals thing? See how they give it to you right in the problem? They'll have to give it to you on this. This is right after Regents question. Okay. Does anybody see something jumping out at them right away? Double angle, really bad. Okay. So this part we have to get rid of. Now the problem is when you guys are doing cosine double angle, you have 3 different options. We need to choose between these 3. Anybody have an idea how you're going to do it? Good. Yep. Yeah, you're right. Both of you guys. Good job. Okay. You want to choose the one, since you know something about cosine in the problem, you want to choose the double angle formula that has only cosine in it. So we want to use one you guys just said. That was great. 2 cos squared A minus 1. Here, I'll tell you for kids. Let me do. So you're going to make that substitution. Everything else is going to stay the same. And then make sure when you guys do your 3 on the outside, make a parenthesis. So 2 cos squared theta minus 1. Yeah, good. Then distribute it through. Try that part.
I'm just watching.
Oh,
Alright.
it's going. I know. Alright, so you're getting there. Holy cow. These are so long. When you guys distribute through, we should get a 6 cos squared theta minus 3. Yep. Yeah, nice read. I would do that first. Yeah, I like that. Mine. Make sure you're not switching any signs because you're not crossing the equal sign here. So you're just combining your like terms. So we should get 6 cos squared theta minus 1. Alright, anybody next up? Bring that thing over. Yeah, you want to get it equal to 0 because your highest exponent is squared. So bring this over. Is 6 cos squared this a like term?
No.
No. Good, it's different exponents. Alright, so let's put this thing in standard form. Oops, grab my data. Okay, alright. Anybody think they know what to do now? Factor, good job. Right, you guys can factor. What else could you do if you hate factoring? Right, we could do the grouping method.
Or the quadratic.
Or quadratic, nice, quadratic formula too. Right, whatever one you guys want. Okay. What in law school do you guys want to do here? Quadratic, grouping, yeah, whatever you guys want, we should all have the same answer, so. What do you usually do? Do you do quadratic? Usually do factoring. Alright, let's do some factoring then. I gotta learn the NFDS thing that somebody only does. So you do something with, you do grouping? I do guess and check.
Yeah, it's factor.
Yeah. I like guess and check the best. Grouping is good, but it takes so long. Alright, so if we multiply 6 times -1, we get -6. Okay, so we need things that multiply to -6, but can make a -1. 2 and 3, good. Alright, so we got our 3, we got a 2. Which one's going to need to be negative? The 3, good, okay. Now, if you guys don't want to use cosines anymore, if you're more comfortable with making this like 6x squared minus x minus 1, that's okay. Alright, you can do it from here and then put the cosine back in. Alright, so let's take out the middle term, we'll put these two in. Get rid of it. So we have 6x squared minus 3x plus 2x minus 1. You guys are doing a really good job of solving this stuff. Alright, when you have 4 terms split down the middle, we're going to do the GCF for the first one. Anybody know the GCF? So yeah, good job. And then we have 2x minus 1. Well, what did you take out here?
Positive 1.
Good job. Yep, nice. Right, remember, bubbles should be the same, which they are, so it's looking good. Join our GCFs together. So 3x plus 1, and then 2x minus 1. Alright. That equals to 0. Right, you've got to find x. What would you guys get if you set that one to 0?
Negative 1/3.
Negative 1/3, good job.
What do you do if we get,
And then x equals 1. Alright, so we're not done. Alright, remember though, even though we thought this is x, we didn't start with x. What did you guys start with? Cosine. Sorry, that's okay. Everybody does that. Make sure if you're changing, you remember which trig function you were using. So, let's put these back in. We have cos x, or cos theta, is equal negative 1/3. Cos theta equals 1/2. Now let's use our second function key to figure this thing out. So second cos negative 1/3. Second cos. Now look at your direction to where does this thing need to go? 10. Good. So far this is looking pretty good. If you had stuff that you can't round, that way you go to school, we did something wrong. So 109.5? Yeah. Right. This is definitely going to be a 6-pointer if you guys got one of those. Holy cow. Okay. So watch out for this though. Are you done with this one?
No.
No, because you need where cosine is negative. So let's draw ourselves a little picture. See, good. 2 and 4 you said? Yeah. Oh, wait a second. I like the 2. 2 and 3. Yep. That's okay. Alright, so let's see. 109.5 is going to be like right into that second quadrant. So that's good. But this always bugs you guys. How are we going to move into the third quadrant? What do you need to find first? Yeah? Good job. Yes, you got to find the reference angle first. So we need to figure out the distance between these two. Yep, good. Why don't you do that for me?
70.5.
70.5, great. Okay, so this reference angle, remember, it's not an answer, but it's going to help us move into our quadrant. So now let's add 70.5 to 180. 250.5. Perfect. All right, so I'm going to add that to my answer. 250.5. All right. I hope you guys know that.
Okay, instead of having to find the reference angle, I just subtracted 360 from 109.5, got 250.5.
It'll work if you're in S&T, but like let's say you were looking where tan is negative or something, and you did these two, it won't. So it'll only work if it's like reflected perfectly. So you can do this sometimes and not all of them.
Wait, what? You add?
So you add, this, no, it's okay, you add it to 180 because you want to do this quadrant, and we're going to positive.
We have to add it.
Yeah, gotcha. Do the 180.
Okay, that's what I did.
Right. I know, yeah, I think you did this part, right? What's your second function of good 60 degrees? Now here, cosine is positive. Okay, so 1 and 4, good. Okay, so we got 60 already. That's already in the quadrant 1. What about quadrant 4? 300. Nice job throwing back 60 degrees. Holy Toledo. So we have 4 answers here. Okay. This is a lot. This would be 6 points. Now, if these questions show up, let's say you factor wrong, okay? We grade on your mistakes. So when you guys are going through, as long as you do stuff correctly based on your wrong work, that's okay. So I think you guys have kind of been seeing that, right? As you graded, like you could still do stuff wrong, but your procedure's right. All right.
Well, Kirk and Sean Putnam, please report to the main office.
All right, this would be the most beastly problem you would get with these. All right, the way you start it is difficult. Let's just ponder it for a second.
Yeah. If you divide the 2, you have to divide by the side, and you divide by that.
The cos squared thing is actually fine. You know what I mean, Frida? It has to be that right side. Alright, so do you guys have any double angles in here? No. No, okay. So we have no double angles. We have 2 different trig functions, but notice they're squared, right? Okay, so let's go back up to what I told you guys. When they're squared, what are you probably using? Yeah, good. Alright. So when you guys are talking about when one of them are squared, or you have multiple ones that are squared, we're probably using some type of an identity substitution. So let's go back to this thing now. Okay. What do you have more of, sines or cosines?
Oh, so you can sub in the 1 minus sine squared for cosine?
Yeah, perfect. Good for that. Alright. Since you have more sines, you want to get rid of cos squared. Because you guys know your first identity, sine squared theta plus cosine squared theta equals 1. We want to think, how can we solve for cosine squared? Well, if we minus sine squared, 1 minus sine squared equals cosine squared. So what we're going to do is get rid of that cosine squared, and we're going to put 1 minus sine squared in its spot. Everything else, I'm just going to bring down.
Are the 1 minus sine squared theta, is that connected, or can you like?
No, but you can combine your like terms now. When you sub it, it's connected, but there's no like distribution out in front or anything that's going on, so now you can combine it. That's good for you. I like that part. So if you combine those, you're going to get a negative 1. Oops, sorry. Okay. And your highest exponents here are squared, so let's make sure you get everything to 0 first before we try to do any kind of factoring. Right. You want the squareds to be positive, so let's add the sine squared over. I'm going to add the 1 over too. Okay, 2 sine squared plus 1 sine squared is going to give me 3 sine squared minus 4 sine theta plus 1 equals 0. Okay. Alright, so we have one trig function. Life is looking good now. Any of you? Kind of looking good. I don't really know how good this is looking, but you do grouping, you do guess and check, or you can use quadratic formula. I know, sorry, page. They're so long. Alright, so these things I multiply to 3, that can give you a negative 4.
3 and 1.
Yeah, good. We don't have a lot of options. What do they both have to be? They're both negatives. Great job. Okay. And again, if you guys want to make these all into x's, you can do that. As long as they're all the same trig function. Okay, so let's take out this negative 4, and let's put these in its spot. What is your What's your GCF?
3x.
Good. 3x. Perfect. And you have x minus 1. What about the GCF over here? Negative 1. Make sure you take the sign out too. And then do your GCF out of there. And then if you divide these, positive divided by negative is still going to be negative. So we should still have the x minus 1. You join your GCFs together. You're going to 3x minus 1. You write that bubble one time. Watch out, especially when you're studying this one, Dad. What did you guys change them all to? Signs, right? Oh no, you're right. Yeah, we're gonna set it. We're gonna set it equal to 0. We can do that first if you want. That might be easier for you. So if you set these all equal to 0, and we should have x equals 1/3, x equals 1. But when you do your sub back in, make sure you use sign, because that's what you changed them all to, right? So just make sure you're careful what you turn them into. Okay. We have sine x equals 1/3. Sine x equals 1. Good job, Anna. I like how that was one of the things you look for, right? They have to tell you guys where you want to round to nearest degree. Looks good. It's the second sine of 1/3. Alright, so nearest degree, 19. So x equals 19 degrees. And notice sine is positive, so where else do you guys need to check? A and F. Good. Okay. So we already have 19 in A. What do you think, Sam? And then we Sheila, what do you think?
180 minus 19.
Yep. Go for it. 161. Perfect. Okay, good. So we got 161 too. Oh, I like when we get 1. Alright, so second sine of 1. You got 90? Great. We got 90 degrees here. And just make sure when you guys have those 1, 0s, or negative 1, right, do a quick check with your order pairs. Is anywhere else the sine 1? So the sine is the second one. No. Yeah, because this is the only spot. So only at 90 degrees. So all 3 of these should be your answers. Whew, those are deep ones at the end. You don't know. It could be it. I don't know. They are awful.